And we're live. Welcome back, everybody, to another episode of Z.I.P Talks. Today we're joined with the winning alliance, um, uh, 18763 Texpand. I lost my train of thought there. My name's Anish. I'm a builder as well as co-outreach lead on Team Z.I.P Ties.
My name is Krish. I'm a programmer on Team Z.I.P Ties.
My name is Shreya. I'm a programmer on Team Zip Ties.
I'm Josh. I'm a lead programmer and a senior builder on Texpand.
My name's Ben. I'm the CAD lead and senior builder on Texpand.
Well, thank you guys so much for joining us today, and we can't wait to talk to you guys about a little bit about robot reliability. So, I just want to get started right off the bat, and I have one really big question. How do you guys kind of look at optimizations and really get your robot like have a good design for your robot as soon as you get like your season like the season challenge? So like after the kickoff and everything, what is like your first step that you guys go into for robot design?
So what we do is we look at the game and we decide as a team what our critical success factors will be for the robot. So we'd be like, we need to have like such a this second cycle time, or we need to be able to do this at the same time as well doing this. Our robot needs to be able to drive this fast. It must be this light so we can drive that fast. And then basically then we go to designing the robot with the ready stuff in mind that narrows down what the designs we have to test, because we're like, okay, that design can't do say 5 second cycles, so then we don't even try test it because it can't meet our critical success factors.
Okay. Yeah, and then
Yeah.
like as far as like what you guys look for within the game, do you guys go for more of like a teleop strategy or an autonomous strategy when you like design your robot?
I think that for the most part, we try to kind of do both simultaneously as best as we can. We haven't really in the past or in this current season, we aren't kind of considering, okay, we should focus more on autonomous over teleop. I think the main thought for that is that, sure, we could specialize in one now, but that could lead to a downside in the other one in the future, which means that at Worlds, it's going to be difficult to be competitive because you actually have to be good at both. So it's better to
Mm-hmm.
start, at least from what we've seen, is to start at a slightly lower level in all of them, but have like all of them similar, and then build it up throughout the season so that when you get to Worlds, you're at a high level for all of them. If
Yeah,
that
and
makes
that's
sense.
kind of like how we do it as well. We like try to figure out, we try to optimize it for both. It's been
Mm-hmm.
kind of difficult this season because like there's not been a really clear autonomous like a layout for autonomous given out this year. So we're kind of having to like a bit like freestyle a little bit here and there, but we're definitely making it through. Um,
Yeah.
yeah, and then
Yeah,
like
it's interesting
yeah.
because there isn't like a randomization this
Hmm.
season. It's a very different game overall.
Yeah.
I mean, I guess it makes it kind of easier because you actually aren't deciding between auto or autonomous. You're just building a robot that can do samples or specimens or
Yeah,
both or whatever.
exactly. And like I think it gives the teams a bit more freedom as far as how they want to make the robot and how they can get it even more reliable than like say if you have a randomization with like some sort of vision pipeline or something like that. It's a lot easier for teams to design a robot. And I guess this is a good season for rookie teams as well to start getting into FTC.
For sure, yeah, for sure.
Yeah. Do any of you guys have another question? Chris, Shreya?
In terms of robot reliability, I wanted to know how you guys sort of balance getting error correction along with like quicker sample rates, because if you have like a really long tedious process for error correction, then your sample rates aren't as fast. So it's like, how would you balance that?
That is interesting. I think that it's a bit of a trial and error to get to the sweet spot. You know what I mean? There's not really a formula to get there, and I think that like that kind of comes with balancing out our teleop versus our auto as well. It's like we start the season with we always try to start with more error correction and more reliability and more kind of fail safes built in at least, and then we slowly take out what we think we don't really need to increase our loop times, cycle times, whatever. We're just optimizing the robot, and that's kind of been our kind of strategy throughout all of our seasons. I think is that we just build something that's working. It doesn't matter how fast it is; it just needs to do the task, and then after that we optimize and we try to speed it up as much as possible.
And then yeah, kind of looping
Yeah.
back into that as well. Like, do you guys reiterate throughout the season? Like, do you guys change like full ideas, or do you do like minor tweaks to your robot throughout the season? Like at from like
So
your basic leagues to like beyond.
So what we do is we kind of have like 3 sprints. So we'll build a working robot. We'll try to get it to do everything, and then after that we'll reevaluate the design. We'll be like, okay, it was good at this, but it struggled to do that very well. So the next one, now we're going to build one that can do that very well, while still keeping all of the good stuff, but improving where we need to. And we'll do that like 3 times, and then do our final build, learning from all 3 of those sprints to get our final robot that we will have in a competition.
Okay.
Yeah. And one thing to add there is we actually only have 2 competitions before Worlds because in South Africa there's only like last season there was like 35 teams in the whole country.
Wow.
So there's a regional event in January, so we have a lot of time. And then we have our national event in February, a month afterwards. So we actually have quite a lot of time, like 3.5 months at the start of the season, to go through that iterating process.
Okay. Yeah. I never actually knew that there was only 35 teams within South Africa. I thought you guys had quite a bit more. Um. Yeah.
Well,
Thank you.
this season it's looking like a lot more. It's looking like
Mhm.
about 60, so it's
Okay.
improved a
So
lot.
yeah, doubled quite a bit. That's pretty good.
Hmm.
And then as
Yeah.
far as like programming goes, like teleop optimizations, how do you guys decide to come up with those to kind of make sure they're like working throughout each competition and they don't like fail on you randomly?
Mm. That's also an interesting one. Again, I don't know if we have a specific way of doing it. You know what I mean?
Yeah, yeah, yeah.
But I think that most of the time, and I'll give an example for center stage. When we're looking at optimization, we spend some time looking at can we automate the kind of pathing of the robot? Like it's collected, now the robot's going to take control and it's going to drive to the backdrop, and something like that didn't really work because of congestion, right? Like we saw
Mhm.
last year, it's very
Yeah,
difficult to go through there
yeah,
without the
yeah.
drivers looking at it. So one thing that we did optimize last year, and added automation in was the collection, right? Because we saw that um, the drivers having to be on the other side of the field from where they're collecting, it's very difficult for them to see what they've collected, especially if there's more than 2 pixels in the wing, right?
Mhm.
So I think that's our process for kind of getting there has more been we get our first sprint working with almost no kind of added sensors in terms of optimization or taking load off the drivers, just very manual controls. Then we put it on a field and we test it, and then we can see where the choke points are, right? What most of the time it would be that like the collection from what we've seen. And the choke point then is like when the drivers are getting stuck, when the robot's not driving, right? Because you want your robot to be driving as much as possible, because
Yeah,
if it's
yeah, yeah.
constantly driving, it's going as fast as it can.
Mhm.
So that's more what we do. We just get a first robot working without any optimizations in terms of teleop, and then we just see where the bottlenecks are. We do testing for each kind of phase of what it's doing, and then we see what is slowing us down. Can we optimize this section? And then we try that.
Okay. Okay. Yeah, I mean that's a good idea as well. That's kind of how we also go about it. I mean, when we first get the game challenge, we're like, okay, this can be optimized, this can be optimized. Like, we can definitely like, especially for this challenge, we can be like, oh yeah, if placing in the top bucket, easy optimization. You can just automatically do that, press one button. Lets the drivers, get back to driving, focus on more important stuff around the field rather than, having to
Yeah.
place. So that's kind of how we think about it. Just like, going through the whole game challenge, taking a couple days and reviewing it thoroughly, going through the competition manual and um stuff like that. Yeah.
Yeah. I've got one question for you then.
hmm
I'm curious because I haven't seen a lot of other people look at it, but did you guys look at all in terms of optimizing kind of driving at all last season at all? In terms of
Um,
like,
as terms of
yeah,
in terms of last season, I don't believe we did. It was all pretty much yeah, driver controlled, no really optimizations in that aspect, just because of how like fast paced that field was, like how fast paced all the robots were going in that game.
for sure,
There
yeah.
was there's not much you can really optimize in my eyes, at least. Like I the like with your robot, it's just you
For
have to
sure.
kind of get around the field, and there's a lot of different people crossing around you, so it's a lot of maneuverability on
Hmm.
that part. Yeah,
For sure, yeah, yeah.
yeah. I think
In
this
Makes
terms,
season
sense.
you could.
yeah, and then I have a
Yeah.
question for you guys. In terms of robot reliability, how well or what do you guys do to prevent crash? Anything relating with the crashing or error correction, like Shreya was saying.
Ben, do you want to answer this or?
Um, yeah, I mean, In terms of braking, we kind of do a lot of driver practice, like mechanically braking. We'll do driver practice and stress test it as much as we can. Like even if there's a scrimmage, we'll take it to that um, and test it. But in terms of programming, I got no clue. I don't
So,
do
so
programming.
yeah, can I just ask a clarifying question? When you mean are you talking about fail safes specifically, or like catching errors out of your code so that your program doesn't crash, or what specifically were you meaning?
Fail safes in terms.
Okay, cool. Okay. Yeah, so most of our fail safes again come from like our first testing. So like our first sprint, they were like, okay, this couldn't work. For example, and a lot of our fail safes actually come out of wanting more speed, right? Because like I was saying, we always get something working first, but that could be really slow. So we often add stuff in, add extra sensors, add fail safes, right? To speed up that process. For example, for dropping off on the backboard last year on autonomous, we before would have our robot drive in line with it, right, and then go down and drop. But then we added an arm that could go out the side. So then what we thought was like, well, we could actually speed this up really fast. We could actually drop the pixels um without stopping. So we thought, okay, let's add a touch sensor onto the claw, onto the back of the claw, and we tested it like by just with just with an arm with a sensor on it and just hit it ourselves, and then just have it auto release and flip the arm back in. And that was actually really effective. We when we were testing it, we had the robot and the arm out just manually, and we would push the robot like from accelerate it really fast from about a meter away and just go against the board as hard as we could, and we couldn't get the arm to get stuck. Like it would literally instantly drop and just retract. So stuff like that in terms of adding sensors was just like, as we need optimizations, we add that. I think the thing with actually in the software in terms of fail safes and stuff like that is something that I've found and that we had really big problems with in PowerPlay was that adding, and I'm sure you guys know this, but it's just one of the big things I like iterating on or talking about is that you need to make sure you don't have any sleeps in your teleop or any while loops. Because if that gets stuck and your condition doesn't get met, you're doomed. Like we had in our PowerPlay robot, we had a short extendo to collect. And at one point during our match, they got stuck out on the way back in, and we were just stuck because our while loop was like, we're not in yet, we got to keep going, and we were just like doomed for the rest of the match. So stuff like that, implementing a command system or finite state machines is probably the biggest thing I've seen, at least, to make sure stuff doesn't like get stuck. And always make sure you have some sort of manual override, because if you have an automation, it's likely to break even if you stress test it a whole lot. So you need to have some way of overriding it.
I completely agree.
Mm.
You brought up the point of extendo. So I think that's one of the biggest things that people are going to be doing this season. And how do you think, like, how is that the 42-inch max extension like affecting you guys? Because I know, like, when we first thought about it, we're like, oh yeah, we'll just extend like really far. But then we read about that 42-inch extension, and now it's like, oh, so now we have to actually add mechanical stops and maybe a stop in the program to quit stop from extending. How is that impacting your like build process?
I think it's just something that we've kept in the back of our mind, like in the critical success factors again. Like we need to be able to stay within that size limit. And how we are like maxing out our extension is having the shortest robot possible in terms of the actual drive base, because then you take up less of that 42 inches. So you have more of your extender over the submersible at max extension. And then having a deposit quite short so that it doesn't go far out the back.
Yeah. Yeah, that's true. That's true. Yeah, because we were like definitely thinking about that. How if we want to like maybe intake and outtake at the same time, how would that play out? But with that 42 extension, that means you have to cut down some position. Um, yeah.
Yeah. It would be very interesting because it's like you can see why they made the rule though.
Hmm.
Because if you had a robot like Robo King's Aurum, right, with slightly more horizontal extension, you can just sit in one place and
Yeah.
cycle to the top basket.
Yeah, that's what we were
So
thinking originally. We're like, if what if we like stretch that out, but then that 42-inch extension really limits it. So I guess that's like the whole
yeah, for
purpose of
sure.
implementing it, which means, you know,
Yeah, because
yeah.
otherwise you just sit in one place and just go
Hmm.
foop, foop, foop,
Yeah.
nothing. It's a very boring game.
Yeah, that's true. That's true. I
Yeah.
think that really spices it up and allows people to drive around and actually, go to the observation zone to make specimens or, drive to the buckets. So,
For sure, yeah.
Yeah.
Because it's interesting. I don't know if you guys encountered this because Ben was saying about like the size of the drivetrain. The
Hmm.
42 inches is like doesn't give you much space if you want to have extendo to like extend to the other side of the submersible.
Yeah,
It's like very limiting in terms of what you can do with your drivetrain. You like
exactly.
have to be like really short. It's
Yeah.
super painful.
Yeah, and even with that 42, like you said, we can't go to the other side, so you have to go all the way around and use up that time to then grab from the other side, which is, I mean, I guess it adds that competition factor, and
Yeah,
it makes it a little bit more competitive. So it'll be interesting to see how a
for
bunch of
sure.
teams do it that way as well.
Mm,
Yeah,
for sure.
yeah. As far as like the specimen, how have you guys decided to go about using the specimen opposed to the sample?
Mm, we actually haven't found. I don't know if you want to talk on this, Ben, or I
Um,
can.
I can, yeah. But the thing with the specimen is that it's your line specific, whereas the yellows aren't. So if you can get more than 20 yellows in your top basket, then they are at a disadvantage in terms of how many points they can score. So I think it's going to be a lot of teams going for the yellows first because they are neutral, and you can limit the amount of points the other team scores by cycling more than them. So I mean, yeah, can be if you can't do samples, no specimens, you're gonna lose, but maybe you don't have to do them as fast.
Yeah, that's
Yeah,
true. I never
that's
actually
a good
thought about
point.
that. Like, taking control of those neutrals and scoring those into the buckets in the net zone and then going for the specimens. Yeah.
It's
Yeah.
interesting because like you can fit if you place them pretty nicely, right? You could fit like 20 yellows in your top
Hmm.
basket, which means that in theory both alliances can do 20 each, right? So that's all of them.
Yeah.
But if you get 20 in your top basket before them, there's something to think about having cycling the rest as many of more of the yellows as you can into your low basket. Because sure you get a lot less points, right? You only get like 4, I think, right? But if you think about it, you're scoring 4 points, but you're taking away their ability to score another 8 in their top basket,
Yeah.
right? So
Yeah.
you have like quite a big deficit. You have like a 12, you're actually gaining like 12 points by
Hmm.
scoring one in the low basket. And so I think that could be a pretty, like, it's just a thought at this point. Obviously, we haven't had people who can score that many,
Yeah.
but it seems like it could definitely be a possibility. I don't know
Hmm.
if you guys have thought about that.
Yeah, I mean, I think that's definitely something we are going to think about now. I never actually like, you know, took that into like retrospective, like, like taking the neutrals from the others, like from like stopping them from scoring the neutrals, and then you taking them and putting them in all of your buckets. And I think that's gonna be really cool to see teams doing, especially with a lot of I think the claws can be the most used intaking and outtaking method this year, especially from placing it in certain areas on the bucket and stacking correctly. I think that's going to be the most useful method, but I think that's going to be a really big thing on how teams are going to, pick up and try to take points away from the other lines.
Yeah. It's been very interesting to see like the difference, sorry, the difference between or like on the Discord at the moment. And obviously it's not a great representation of like what everyone's doing,
Hmm.
but it's like the fight between active intakes, claws, who's
Yeah,
gonna win. And
yeah,
you saying like claws, and I'm like, it looks right now like a lot of people are doing active intakes. So
yeah.
it's
It's
like
like I was
it
looking at
could
the
be
Discord as
either.
well. It's like a mix of both, and it's like
Yeah.
it depends. It really depends on how you, I guess, build it yourself and how you test with it and what works for you as well as like how well your drivers can use it. So I guess in that aspect
Yeah.
as well, it's
Okay.
about a bunch of human error. So never know.
Yeah, I'm quite impressed actually by the game that first made this season. It's like it could be either, like you're saying, whichever your team's better at doing
Hmm.
is what's gonna work. And it's very interesting that there's not like a meta design, you know what I mean?
Yeah.
Which has been in the past.
Yeah, like especially
So it's
last
very
year, there
interesting.
was like a lot of consistency with all the designs. I think this year
Yeah,
is like a good representation of what like just free building is. And depending on like how well your drivers can communicate with each other, like if say you have a bunch of people who are like really good at driving the robot and moving their fingers around, they're able to use maybe a claw and use precise like precise dropping methods and precise intaking like that. So I mean, just yeah.
for sure. Very interesting.
I feel like the neutrals would be kind of like the contested high junction in power play. Like, how would you avoid collision, or I've seen like in previous autonomouses, like Wolfpack had like an automatic collision, like almost removal. Like it would kind of, even like as soon as it sensed another robot, they would automatically just like back away, and then they would continue doing whatever they're doing.
Hmm. It's interesting for sure because if you're talking specifically autonomous, I think that it's going to be actually the only syncing you have to do in this autonomous is actually with your partner, right? Because the opposing alliance can't cross the line. Well, they can cross the line, but if they interfere with you, they get a major. So it's very dangerous. But if syncing up from what I've seen and what we've been thinking mostly as a team, and we haven't given it a lot of thought, but it seems like syncing up to place in the top basket, like the samples in autonomous, is going to be quite difficult and a bit of a waste of time because you can have stuff like people had last year, like robot detection, right, with a distance sensor, or just by using the velocity of your robot to figure out if you crash into another robot. Although I wouldn't suggest that. Um, but if you have a distance sensor to figure out, okay, they're placing, now we're going to wait. When they leave, we're going to place or whatever. That waiting time, because this game is so little driving and the cycle times are quite short, that waiting time could take up a full cycle and cost you a 16 points, right, of cycling another yellow to the top. So, in my opinion, at the moment, and obviously we haven't seen any games, but I think that the best would actually be to have one robot run a sample auto to the high basket and the other robot to run a clipping auto, a specimen auto, collecting from the human player. Because that's very interesting, to be honest, this season with the human player being active and
Hmm.
autonomous. It's going to be difficult, obviously, because the human player can't place it perfectly in the same place every time. But I think that could score you a lot of points as well. So having them both at the same time means you don't have to slow down. You can go at your own speed, and get the max points as an alliance. I think that's the best way to get it.
Yeah. And you're on two separate sides of the field as well. They have the neutrals on one side and the Alliance Pacific on the other side. And they made it pretty optimal actually as well. So you just have to push it into the observation zone and then they can make a specimen. So, I mean, yeah.
They made it very nicely.
Hmm.
Yeah,
And it's completely mirrored
very
as well. So autonomous works on both both the red and blue Alliance. So,
yeah,
Yeah.
yeah. It does. Although I kind of gonna make it. I'm gonna mirror our autonomouses probably just because I don't like the idea of having because like we use a global coordinate system, right? So the one side of the field's always zero and stuff. So I could just flip it and then but then the whole coordinate system would be inverted.
hmm.
So and it would work fine, but I just don't feel like that. It feels wrong. So I'm gonna invert all our autos, I think.
Well, yeah.
In terms of programming wise, what things do you think will be essential for this year's game challenge? Like I know last year you guys had a really good auto. You were touching on that a little bit, but for like auto and teleop this year, what do you think is going to be really essential code wise?
I think that your driving, I think we did some looking at it. We haven't done a lot of looking at automation for autonomous yet, but looking at it, I think driving is actually going to be a bottleneck. You wouldn't actually think it when you look at the field, right? You don't drive very much. But
Mm-hmm.
looking at a drivetrain with like, I think we looked at driving with about 460 RPM drive motors. And that will still take you around 2.4 seconds, I think it was, or 2.3 seconds to travel there and back. So you are kind of limited, I think, with fast slides, with like fast if you're using extender and fast delivery slides. You're going to be able to do that, have your slides up before you get there. So I think speeding up your driving as much as possible and optimizing that, and like having your driving work in such a way that it decelerates perfectly to the target position. And this is something we had to work on a lot last year. But like, if you get to the position, but you're like half a centimeter off or something, that is such a big waste of time because you can't just get there fast, right? So you need to make sure you're correcting along your path or whatever. So I'd say that's a big thing we've thought of. I don't
And
know, Ben. Yeah.
stuff like heading lock, say, to the top basket, so you don't have to turn to align to that. So you could have a box with your odometry to just turn you to the right heading and even put your slides up, so that the drivers don't have to do that. So stuff like that will just help the drivers, so there's no less driver error because the robot will do the same thing almost every time, but the drivers can mess up.
Yeah, for sure.
I remember last year we would often like align to the April tags because those were so like well placed. What do you guys think of using April tags this year though? Because they're not as like well placed. They're kind of scattered, kind of like the images.
Mm.
on the sides of the field.
We have got cameras for April tags now, so we probably will use them at some point. We haven't really thought about where we're going to put them or where the April tags are, to be honest. Um, the problem with the April tags and the reason we actually didn't use them at all in center stage, we experimented with them, but we never did, was just we found it to be too slow. We couldn't get it to work like reliably, even while the robot was no okay. So we got it working when the robot was at a standstill, right? But we eventually got our delivery working so fast that we never even stopped moving. So there was no way we could actually use those to reset our robot. And we didn't actually have a global shutter cam at the time, so it was a bit pointless and it wasn't a priority. But I think that like Ben was talking about, having that optimization with odometry position in teleop means you have to have really bulletproof localization. So as many ways as you can kind of centrifuge into your localization. If you can do it effectively, you're going to have much more chance of having like reliable driver. I mean, in auto it isn't as much of a problem because it's only 30 seconds. But if you're doing it throughout driver control, your reliability and your position will drift a lot if you don't have some way of kind of resetting it or adding to the odometry pod's reading.
Yeah.
Yeah, in fact, I think for last year we experimented. It was like our first time experimenting with odometry in teleop, but I'm not really sure, like, because there are a lot of different places where either driver control is better and then having it automated is also better. So, how would you determine what kind of situation it is based on the like how quick the teleop is? Like, how do you
Ben, do you
determine
wanna
whether it's better
Ben, do
for
you wanna
automation
Um,
or for teleop?
I
Yeah.
think basically just as a driver last year, we just would have driving practice, and I'd be like, "This I don't like doing this. This is not working well. Okay, I'm messing up here. Can we automate it? Okay, we can automate this part. I must just practice a bit more on that part, get better at that. So basically, just run a drive practice and say, okay, if we could speed this up, then that's if the robot's not being maxed out, like in terms of the speed mechanically, can the drivers find a way to improve or automate automate the process that they're struggling to speed get faster at basically.
Yeah. I think it all comes to down to, like he's saying, is like if the drivers are having to do like two things at once, right? Then it often means that it's going to be slower, and it also means that um you have a lot more opportunity to mess up because they're like trying to do two things at once or something. So if it's possible to automate the driving, which is actually probably often the easiest thing to automate, just because of all of the interference with like the collection or the delivery, um, and like make sure you're in the exact right place. Um, Most of the time, the driving is actually often the easiest, and I think in this season especially because you don't have interference as much from the opposing alliance, you actually have that space to go, okay, we can actually almost automate the entire driving process, and the drivers can just focus on let's get the slides out in time so we can like be ready when the robot gets to deliver. We can instantly drop and then go. That means they don't actually have to think about the driving. They can literally just be like, this is, we're busy transferring, now we're going to delivering. Okay, the robot's there. Okay, let's drop. And then they can start thinking about collection straight away.
Yeah.
I have one build question. Have you guys started thinking about like what type of intake, transfer, and outtake system you guys are going to use for this year?
Um, I don't think as a team we have decided to share our design yet, so
That makes sense. That makes
I
sense. I
I
was just
can't say.
wondering. Yeah.
Yeah,
Yeah.
Yeah.
sorry.
No, that's fairly fine. Chris,
Yeah.
you have any
But I
programming
mean,
questions?
like I was saying at the beginning, like it is interesting for the collection that like it's both, right? And that's
Mm-hmm.
something that we have been thinking about as a team a lot, is like which one actually will be better. And I don't think we're fully decided yet, to be honest.
Yeah, that makes sense. Yeah, it's still pretty early on within the season to kind of have a final robot design. Um, I know we're definitely looking at a bunch of different like robot in 30 days or robot in 3 days. A lot of those videos, people who have posted like kind of designs, take some inspiration, see what other teams are doing, and kind of get a scope of how the competition is going to play out this year. So,
For sure, yeah.
Do you guys think that having like a error correction system or a detection system is necessary this year? Because not like last year, I know that during Telep and Autonomous, some of the robots would always collide while going through the center stage door, going to the wing. We saw a lot of robots colliding. Do you think it'll be necessary this year or not much?
I don't really think so because like you're staying to your most of your sides throughout the game. There's no real point in going to the other side. And then if you have to, or if somebody else comes to try and interfere with you, I would just give that to the drivers to say they have to either navigate around or play defense.
Yeah. One thing
Hmm.
I would say for autonomous is that I don't think I think he's right. I think Ben is right there. Is like there's no real point in doing it for other robots. But I think that though the like legs on the submersible could cause problems for sure. Like you could definitely get caught on those. So I think having something that allows you to be like, this is where we should be on our path right now. We're not there. We're stuck currently. We're not moving or not moving very much. Let's backtrack a bit and try again. Or go around or try figure out a way of saying, okay, let's go around it. But often that's quite difficult because you don't really know where the obstacle is. You're just guessing based on you've stopped and now we're going the other way or whatever.
Hmm.
Yeah. So I think that's something we played around with last year, but we didn't quite get working. Mm.
As far as like the human player and auto, how much do you think it's gonna be used this season? Because I know we've been saying, oh, maybe we'll have the robot coordinate with the human player, and we'll set like a timer or something within autonomous to maybe if we were to cycle specimens, um, we could do it that way. What are your thoughts on that?
Ben, you want to talk on
Um,
that? Okay.
you can.
Okay. So yeah, it is difficult to coordinate with them, for sure. And I think that one thing is that you would think like, oh, having an active intake for this, right, would be quite useful because it's compliant. But then the hook causes the clip causes major issues there because you're like, you don't really know which way it's going to be, stuff like that. So I think the best is that because you can hang them on the wall, right, or you can place them or hang them on the wall. I think it's going to be interesting to figure out if you can find a way that the human player can place it in a specific position, like in line or something, and then maybe have a distance sensor or something that, like, I'm just thinking if your robot's against the wall by the slanted side of the observation zone, then you can place it on the line, right, where it stops slanting, where it starts going straight, and then you can have a distance sensor that's in line with that, and as soon as it like gets shorter, right, then it knows, okay, it's been placed, and then drive forward. And obviously you would need to make sure that your robot's outside the observation zone while it's waiting, but then have it so that it's that way around rather than the human player places it and then the robot comes and gets it, because I think it's going to be more reliable. Obviously it's a bit slower, but I think it's obviously start with reliability and then move on from there. So that would be a thought at this point for me, is like a way of automating it that seems pretty foolproof to me at
Hmm.
least.
Yeah, yeah, that makes sense. Um,
Mm.
do you guys have any questions for us? Anything?
Yeah, I'd actually ask about the question you guys just had. Have you guys thought at all about ways of collecting out of the observation zone? Because I've just had like that kind of thought, but I haven't really thought about it much more. So I'd be keen to hear if you guys have
Um,
thoughts on
as far as like the observation zone, we're like right now, it's kind of like a lot of testing. It's a lot of figuring out does like is mounting the specimens on the wall easier than just dropping it into the observation like zone? It does it take more time? If we were to have a robot like wait there while the human player assembles it and then places it down, which one's more optimal? And then like again going back to that robot design, does our robot design like require it to be placed on the wall or on the ground for it to be picked up accurately without having to maneuver it more once it's already in the transfer? So I think that's probably the biggest thing that we're looking at currently. I think Christian, Trey, if you have anything else based on like the programming aspect of picking up from the human player.
I think that hanging it from the wall would be a little more consistent because it would always be at a consistent height. So based on like your intake, you could have like a preset position for the height, and you could just all you'd have to do is like strafe according to it.
that.
So you could use some kind of
Yeah,
vision just to align yourself. I feel like that would be the best
mm,
option.
that's true. That's true. And like, um, that was one thing like that I thought of as you were discussing that is like, have you guys considered like, I think what we've discussed is kind of assuming that we're doing single way of collecting for the specimens and the samples. But have you thought about like, I know that I think it's the Rev starter bot. I've actually been working a lot with that lately for training and stuff, but they have a separate claw for grabbing the sample specimens off the wall and a separate intake. So have you guys considered that at all? What are you kind of thoughts on that?
I mean, I think the biggest thing is that we want to keep the robot small, so we don't want to make this entire robot like a big elaborate scheme because that 42 extension limit is going to really impact us then. So I think like because we've not of course we're still in the early stages, so we're not like finalized or anything or like come up with a set design. We're more so like looking
Yeah.
towards like is there a way that we can make some sort of intake outtake system that allows us to pick up both the sample and the specimen within the same component, so we don't have to create something else additional to waste time or waste more servos and motors in that aspect as well.
Mm-hmm. For sure.
Yeah.
For sure. I had another question, but I've forgotten it now. Oh, that was the other question. What do you guys do in terms of pathing and stuff? Because that's something well, we developed our own custom pathing last season. So I was wondering what you guys have done, in these few seasons.
So mainly we've just been, I mean, that's another thing that we've also been experimenting with, especially for off season. We've heard a lot of good things, at least in the Discord, about like pure pursuit and PID to point. But as of right now, I think since it's so like early on in the season, right now we're just focusing on how can I get from point A to point B like consistently. We've been focusing more on the error correction instead of like the actual like whole path.
Okay,
Yeah,
okay, that's cool. Yeah.
and then I think as the season goes on, we'll try implementing pathing systems like Roadrunner into our robots so we have more defined paths.
Okay, that's cool.
Yeah. Um,
Very cool.
I guess I just have the same question for you guys. Have you guys thought about any pathing systems? Are you guys gonna use the same pathing system as you guys had last year, or are you gonna do something else?
Yeah, I think we're just sticking with the same thing. So we first developed it. I did it in last year around this time. I spent a couple weeks doing it, and then since then, around we just throughout the season we've kind of been problem solving with it, right? Finding issues, debugging it, and it's kept getting better. This season in the off season, I put it in a library, and now we're just using that as well. We've added some other stuff to it, like curvature. It's very similar. I don't know if you've seen the video by Wolfpack
Yeah.
on their pathing. So it's a similar idea to that, and that was one of the videos that gave me the inspiration to do it. Generating with Bezier curves, then motion profiling it, or smoothing and then motion profiling it, then following it with uh, feed forward controllers and PID controllers. And then now I've added stuff like the curvature, adding accounting for the curvature as you go along the curve to follow the line properly. But then main thing this season will be we're actually trying to kind of smooth out our loop times probably. Because last season we had quite inconsistent loop times. I think we were going between, I'm not sure, I'll be guessing, but I think it's like 20 to 30 milliseconds, maybe sometimes up to 35, a loop. But I think this season we're aiming for much better, hopefully more consistent as well, because I think that's what messes up the odometry a lot.
Mm-hmm.
Yeah, loop times were pretty big. That's kind of why at least for curvature we kind of put that on hold and we decided to make it like relative movement. And also like in general for I think we were talking about the curvature. Yeah. So like turning while moving, typically we've noticed a lot of drift when we try to implement turning while moving. Like, is there any way you could like counteract that with maybe localization or maybe like heading lock, like you guys were talking about?
That's interesting. I would have to ask, do you guys use 3-wheel odometry or 2-wheel with IMU?
So this year we
Ranking.
actually we changed our we're like experimenting with a new odometry system. One of the
Oh,
new
okay.
we're using the new Spark Fun sensor that was
Oh,
just
okay,
approved
cool.
by First. So we're trying to experiment with that. That kind of gets rid of like all the odometry pods and it does all the math for you and all you really have to do is kind of just place it correctly on your robot. So we're trying to fine tune the robot for that as well as experiment with that system. But we did use three-wheel odometry beforehand.
Okay. So have you encountered that kind of drift with the Spark Fun?
With the
Yeah.
Spark Fun, I've noticed that it's like relatively accurate. The tuning process isn't as tedious, but you do have to make sure that you're like really precise with like the lengths that you're going, and then making sure that your math is right when you're calculating your gain.
Yeah. Yeah, because that's what I was thinking. With that, I don't see why that, with like the optical sensor on that, I don't see why that would cause drifting like more while turning and driving. So I think you should be good there. But I would be, from what I've heard in terms of testing and the metrics, the Spark Fun is easier to set up for sure, but it's more, it drifts not a huge amount more, but like if you're trying to use it throughout of teleop, you're gonna need to for sure have some way of resetting it or um, supplementing its position. Because from what I've seen, odometry pods tuning them is straightforward, but as your loop times get more inconsistent, at least from what I've seen, it gets exponentially worse. So if you can control your loop times, odometry should be, for us at least, was really good. Yeah, didn't really drift.
Speaking of loop times, have you guys implemented stuff like I think I've seen Clueless have like a thing where if it gets to a certain point, it'll like prioritize their sensors, and if it's became to like a certain point in time, they'll just like skip over. They'll say, "Okay, move
Mm.
on to the next time. Move on to the next cycle."
Yeah, that's something that's interesting. Is that I looked at that as well. I talked to their programmers about it as well. But I never tried implementing that. What I actually did was I've I've actually threaded the hardware rights for all our motors and servos because those are what blocks it the most, right? They each take like 2 to 3 milliseconds. So if I can thread those, it takes about 0.1 to 0.2 milliseconds per one of those. And if you do them all at the same time, then it stays at 0.2. Um, and then you do a bulk read, and then you just have space for your math and stuff. So with that, that's what I've decided to implement um, over a scheduler like they had. It just reduces it. It has a lot more potential to reduce it a lot more, but it is a bit risky and inconsistent. So we haven't tested it a lot yet, but it's been fine since the start of the season. So no complaining so far.
Yeah, especially with multi-threading. Like we've been talking with at least like amongst the team and stuff, and with multi-threading, they were like it's good, but like you need to keep your code organized and like well
Mhm.
like structured in order to make the most use out of it.
Yeah, for sure. So that's one thing that we like when I looked at it, I'm like, it makes sense why they designed the SDK in this way because like if you're a rookie programmer coming into this competition and you just manage to somehow send the hub like 1,000 motor write requests, it will be really bad and cause your robot to crash. So they like have a wait, right, until it completes before they move to the next thing. But it kind of does limit your like upside potential. So what I did to implement it was I had it threading, but it will only update when the other one completes, right? So it doesn't act. I didn't haven't actually modified the SDK. I've just I've basically it like bypasses it, but basically it calls a motor right, and then it just chucks the waiting into a different thread, and then just keeps going with other stuff. And then you just have to make sure that you don't call it again while it's busy waiting. And I've basically just made it impossible to do that in the motor wrapper class. And this is not the best way of doing it for sure, but it's yielded pretty good results so far. So that's pretty cool.
Yeah, I think I would look into multi-threading. I just want to make sure the code is like well structured before we get into it.
For sure, for
Like,
sure.
have you guys tried command based or I believe there was another structure as well that I've seen. I forgot the name of it though.
Finite state machines.
Yeah, yeah.
Yeah, so last year we had finite state machines in subsystems, right? Like each of our subsystems of our robot divided into separate classes. But then this season, I wrote a command system using Java Lambda functions and a scheduler. So basically, it's and this is something that's been really cool for us it's is a wrapper class for the op mode for the normal op mode class, and basically instead of importing all of your hardware classes and your constants and your variables and stuff into your teleop or your auto, you just extend the wrapper class instead of the op mode class, and then all of your hardware classes, all of your variables and stuff are automatically imported into that. So most of the time, our programs at the moment have zero imports at the top of the program. It's just all behind the scenes. And then that op mode wrapper handles all of the hardware and the command system. So each of the subsystems has commands, and then the scheduler handles which is the current command that's being called on each subsystem. We're running that command, and then if it ends, we're going to move to the next one in the queue, or just move back to the default command.
Yeah, that's a cool way of scheduling it. Krish, any questions?
I think we
Have
can
you
actually
guys any
wrap it
questions?
up here. We're coming up close to that ending time. Thank you guys so much for coming out and actually joining us and talking to us about this. A lot of good information and a lot of stuff we're gonna take into account as well. Thank you guys so much for your time, and good
Yeah.
luck on the rest of your season.
Yeah, thank you. Thanks so much for having us. And yeah, we've gained some information here as well.
Yeah, of
It's
course.
always good. It's always good when we have discussions like these and we're
Yeah,
like, oh wait, I didn't think
Yeah.
about that.
exactly. Yeah, I never thought of some of the game strategy stuff, but thank you. I
Yeah,
really
Thank
appreciate
you.
for
it.
sure.
Yeah.
Yeah, thanks for having us on. It
Yeah,
was
of
awesome.
course. Thank you.
Hmm